day. I'm stuffed.
I know, seriously.
Oh, my goodness.
Thank you all for participating today. And now we get to reveal the most exciting time in chemistry when we start learning about the mole.
The mole!
And what to do with it. So we have talked in previous units about this crazy thing. Let's see how quickly I can draw it. What is that?
It's a castle. No, it's a periodic table.
It's like playing Pictionary. I love it. All right, so on the periodic table, there was all sorts of information that we were able to glean. One bit of information was atomic number, and another bit of information was
atomic mass,
which for iron is listed as 55.85. Now, what are the units on that, Mrs. Baker?
There's none listed on the periodic table, Mr. Woods.
There isn't. And when we learned about the mass of an individual atom, we learned that this had the units
AMU,
which stands for
atomic mass unit,
which is a totally made-up unit that has no use really practically in chemistry because there are no balances anywhere in the universe that measure in AMUs.
Yeah.
It would be way more convenient if this was measured in a unit that we could actually measure. Our balances work in grams, right?
Yep.
So now comes the question, if I had that mass, what we call the relative mass from the periodic table, in the units grams, and I had a little pair of particle tweezers that I could put atoms one by one onto a balance, how many atoms would it take for iron before I got up to a mass of 55.85 grams?
I bet it's that magic number we've kept talking about today.
Which is?
Is it, let's see, 6.022 times 10 to the 23rd.
Which we've been referring to as?
The mole.
The mole. So
the
that
mole.
relative mass in grams from the periodic table is equivalent to a mole of that substance. So the kind of nice thing is that from all of this, we actually get a couple of conversions out of all of this. One of the conversions is one that better be stuck in your head after today, and it is that 1 mole is
6.022 times 10 to the 23rd particles.
Particles being a generic term that could be, it could be atoms.
Okay, if I'm talking,
what type of a substance would we call the particles atoms?
One of our elements. Like
every element?
Well, of course not the diatomics.
Oh, those would be called
molecules.
Along with crazy things like water or methane would also be a molecule. So is every compound then a molecule?
Well, I remember I told my students when we were going through the matter pyramid that we were going to talk about another type of particle other than a molecule. So guess what, guys? Here it is. The last kind of particle type is called a formula unit.
A formula unit. That's not a good thing to abbreviate, is it?
No. Formula unit.
We'll learn that all ionic compounds, right, we learn are referred to, the representative particle is referred to as a formula unit.
So if I have a mole of sodium chloride, I have 6.022 times 10 to the 23rd formula units of sodium chloride.
You got it.
Okay, got it.
The other conversion that we get out of all of this from the periodic table is that 1 mole of a substance is equal to its mass from the periodic table. From now on, we're going to refer to that mass from the periodic table as, I wrote the wrong word first. We're going to refer to that as the molar mass.
Oh, like the mass of a mole?
You got it. Measured in
grams.
That's exactly right.
So 1 mole, if I want to know how many things I have, is 6.022 times 10 to the 23rd. 1 mole, if I want to know what it weighs, what its mass is, then I need to go to the periodic table.
Exactly right.
All right.
So these actually become conversions no different than the conversions that we learned back when we were doing unit analysis. Like if I knew 12 inches was equal to 1 foot, I could actually plug those into my unit analysis boxes and say, well, gosh, every 1 foot is equivalent to 12 inches, and do the math there and say, then 3 feet is equivalent to 36 inches. Great. Well, we can do the same things basically with moles, with slightly more complicated conversions. These two guys, right? Make sure you have those written down before I move on. I'm stalling for you. 5, 4, 3, 2, 1.
And get a periodic table, because you need a periodic table to figure out that molar mass in grams.
Pause. Get a periodic table so you know what we're talking about. All right, so pick a substance, Mrs. Baker.
How about potassium?
Potassium. Let's say, hypothetically, that I had 2.8 moles of potassium. And I wanted to know, gosh, in that 2.8 moles of potassium, how many atoms of potassium are there? Atoms would be the particle, the representative particle for an element like this. How would I go about figuring that out?
Well, if I know that 1 mole is 6.022 times 10 to the 23rd
From up
atoms
here.
from one of our conversions right there.
Awesome.
Here, if I grab my pen over here,
for it.
I'm going to put 1 mole of potassium down there. Oops, I forgot the E on mole.
Isn't that
okay?
interesting? The abbreviation for mole is MOL, like we're saving a lot of ink by just saving one letter.
And what's the abbreviation for molecule?
It better not be MOL. You better write the whole darn word out.
Okay. Now you notice when I wrote that, there's 3 parts to that, where I have the numeric part, I have the unit, which is atoms, and I also have the identity of the substance. So just make sure you always have those 3 parts. So again, the numeric part, the unit, and the identity of the substance. We'll really need to make sure that we have all 3 of those in our next unit, so let's just get into the habit right now.
That's awesome. Yeah.
Okay.
By the way, when we calculate this, the 2.8 times 6.022 times 10 to the 23rd, we get... Oh, write this whole thing down, Mrs.
okay.
Baker. I've got a whole big long number for you here.
Here we go.
1.6856 times 10 to the 24th. Do I need to write that whole number down?
Do I have to write all those zeros? No. Oh, wait. Do we have to do sig figs?
Ooh, we really do. Looking back at my original number here, it looks like I have 2 sig figs.
2 sig figs.
So round that to 2 sig figs for me.
Okay, it's 1.7 atoms of potassium.
Wait, no, you can't have 1.7 atoms of potassium.
Why not?
We forgot this crazy power of 10.
Oh, yeah. So when you look at your calculator, always make sure you're looking at the end to see if you actually do have that exponent.
And also in your answer, make sure that you've got Ooh, I'm sorry. That's awesome.
Stop that. Stop that. Okay, so this is going to be, again, atoms of potassium.
Awesome. That's it. That's how you convert from moles to atoms.
Easy.
Or particles, or whatever.
Molecules, formula units.
What if we wanted to deal with masses somewhere along the way? Let's say I wanted to do that same amount of potassium, 2.8 moles of potassium. Look at me being fancy and abbreviating. And I wanted to figure out how many grams of potassium that was equivalent to.
Well, see, I'm going to go back. I'm going to go back and look at this. 1 mole equals the molar mass. Oh, we got to go to the periodic table then. And
let me go get one.
Okay. So let's see. You guys should be getting that yourself. So again, I'm going to put the 1 mole potassium. Oopsie. 1 mole potassium at the bottom.
You're really abbreviating. So the 1 mole of potassium has a mass of 39.10 grams for every mole. So that's why we put the grams of potassium on the top, the 1 mole of potassium on the bottom.
Okay.
Plug that into the calculator, boop, 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 and I get 109.48
I'm going to write that off to the side because I got to think about sig figs.
grams of potassium.
It's going to be grams potassium, but I only want 2 sig figs. I guess I need to round that up to 110.
Sounds good to me.
110 grams of potassium.
Ta-da! 2 sig figs in that answer.
Great.
I love it. That's not too bad. All right, well, what if we know how to get from moles to particles? I know how to get from moles to grams. What if I were wanting to get, I don't know, like, all the way from, do that. What if we weren't dealing with an element like potassium? What if we were instead dealing with a compound, like, say, I don't know, carbon dioxide?
Okay.
So let's say I started with 6.25 grams of carbon dioxide, right?
Okay.
How would I figure out how many molecules, let's say, or I guess we can start with getting to moles, right?
Okay.
How many moles of carbon dioxide that would be?
Okay, so I need to go to the periodic table and find carbon dioxide. Carbon dioxide
not on the periodic table. Not an element. So, what do I do?
Well, let's see. Carbon dioxide is made up of carbon.
How many carbons?
1 carbon.
Interesting. And I see some oxygen. How many of them?
2 oxygens. Oh, can I just go, let's see, go to the periodic table and find out what the molar mass of carbon is?
Looks like carbon is 12.01.
Okay.
I have 2 oxygens, which each one of those is 16.00. Do you notice, by the way, when I'm finding the molar masses, I tend to go 2 places past the decimal point. That tends to take care of as many sig figs as we would ever need. Convenient for us to round to those. So here's my carbon, 12.01. 2 times 16 is 32.00. I add those together now, and I end up getting 44.01 grams per mole for carbon dioxide.
Oh, okay, there we go.
Plug that into the unit analysis.
So then this time I need to put the 44.01 grams of carbon dioxide on the bottom, and I'll put the 1 mole of carbon dioxide on the top.
Awesome.
Again,
now,
unit
I'm going to go ahead and plug this into the calculator.
Okay.
6.25 divided by 44.01, and I get 0.142.
Okay.
And I'm going to stop there.
142
moles
of carbon dioxide.
If that's what the question asked, I would be done.
Okay.
But what if I didn't want to know how many moles? What if I find it more interesting to know how many molecules of carbon dioxide that would be?
Should we erase what we have
Can
there?
we back up a little bit?
Okay.
Now, we could have stopped and taken that answer and started a new problem. Or we can just say this is all part of the same problem, and we can just continue on, just like we did in unit analysis when we had multiple steps. What would be the next step?
Well, okay, so if I want to go to molecules, I know there's 6.022 times 10 to the 23rd molecules per mole.
And right now we're gotten rid of our units, grams of carbon dioxide. We're in the units, moles of carbon dioxide.
So I'm going to say 1 mole of carbon dioxide is, again, I want to go to molecules, 6.022 times 10 to the 23rd. I'm going to extend that line there.
Sorry.
Molecules. I'm going to say CO2 molecules.
Right.
So it fits, okay?
And when I plug all of this in now, I end up getting, and I'm allowed 3 sig figs.
Yeah, because remember, we got to start, go back to that original measured value.
Looks like I'm going to get 8.55.
Oopsie. Sorry, not yellow. I can't get rid of that. Here.
There you go.
Okay.
8.55.
Okay.
Oh, shoot, look at the end. Times 10 to the 22nd.
Okay, so so I'm 10 to the 22nd, and again...
molecules of CO2.
CO2 molecules. I wrote that a little bit different than Mr. Woods said, but it, as long as you've got that, all 3 parts of that unit.
And ta-da,
there we go.
My conversion. That's how I can get from grams to moles, moles to grams, grams all the way to molecules involving a 2-step process, and it all comes back to just having and knowing those 2 conversions.
Awesome.
You know those, and you're good, and we'll be able to handle just about everything we throw at you.
Awesome. All right.
Love it. Happy Mole Day again.
Happy Mole Day. Bye.